Distance and displacement. Objectives: to understand displacement, to understand the difference between distance and displacement. Let us consider a fixed position or a point to specify the position of any object. This point is known as the reference point or origin. The change in position of an object is called its displacement. It is represented by S or D. Here the position of the object changes from its initial position xi to the final position xf. The displacement d is given by the final position minus the initial position. Therefore d equals xf minus xi. The direction of displacement is along the line joining the initial position to the final position. In a game of billiards, the player wants to hit the brown ball at position C. We will consider two different ways in which this can be done. Firstly, cue ball travels directly from point A to point C, covering a distance of 1.0 meters. In the next situation, the cue ball travels from point A to point B, covering a distance of 0.7 meters, and then finally reaches point C. The distance between point B and C is 1.5 meters. What is the value of displacement and that of distance traveled by the cue ball in both the cases? Are they the same? Let's get the answers to these questions. In the first case, both the displacement and the distance are the same, that is 1 meter. Let us look at the second case. We know that the distance covered by the body is defined as the total length of the path covered by the body regardless of the direction of its motion. So, in this case, the distance is 0.7 meters plus 1.5 meters, which equals 2.2 meters. The displacement is the shortest distance measured from the initial position to the final position of the body, regardless of the path taken by it. That is 1 meter. Thus, the total distance traveled by a body and the magnitude of its displacement are not the same in the given case. Let us take another example where both are the same. Let the ball travel from point A to point B, that is 2 meters, and then reach point C. The distance between point B and C is 1 meter. Points A, B, and C are collinear. In this case, we find that the displacement and the distance both have the same magnitude of 3 meters. Here, the two measured quantities are the same, if the cue ball travels in the same direction. Thus, in the case of distance, we need to specify only the numerical value. There is no direction associated with the distance, while in the case of displacement, the direction must be specified. Hence, displacement is a vector quantity, whereas distance is a scalar quantity. Now, can you tell what would be the displacement if the ball travels 1 meter and comes back to the initial position xi along the same path? Here, the distance traveled is 2 meters. But as the initial position xi and final position xf are the same, the displacement is 0. Summary. Distance is the total length of the path covered by the body regardless of the direction of its motion. Displacement is the shortest distance measured from the initial position to the final position of the body, regardless of the path taken by it. That is, d equals xf minus xi. Displacement is a vector quantity, whereas distance is a scalar quantity. Displacement and distance are the same if the body travels in the same direction. If the initial position xi and final position xf are the same, then the displacement is 0.